Okay, then let's move on to the questions. The first question is from quiz 5, question number 1. Consider the statements about the dysentery predictors. Which do you agree? The first option is the less questions is more preferable than one with more questions. And the second is opposite. The more question is better. Then, okay, let's answer to these questions. Basically, it asks about the number of inner nodes in the descent tree, means the depth of the tree. As you know, as the depth of the tree increases, the tree is more likely to be overfitted. That means the decision tree gets used to the training set, so it cannot be well performed on the task dataset. Also, the more and complex questions and structure in the decision tree mean that the tree is struggling to find the answer and less reliable. So the answer will be the less questions is the better. The second question is from quiz 6. Consider the statements about the ID3 algorithm. Which do you agree? The first option is the ID3 algorithm will produce a tree of the least number of nodes where on the leaps decisions are consistent with the training examples. This question is wrong because the ID3 algorithm will not produce the least number of the nodes in the tree because it more focuses on the minimizing the entropy when the tree is split. So basically, it will produce a tree of the least and the minimizing the entropy is correct. So this option is wrong. And the second option, at a leaf node of the distant tree, the entropy of the target variable is 0. Then one has a certain value for the target variable of the test data at this node. This is also wrong because even if the entropy of the training dataset is 0, it cannot happen at the task dataset again because the training dataset and the task dataset basically different. They are the different. So this option is also wrong. And the last option asks about the entropy. The ID3 algorithm basically follows a greedy approach using information gain and entropy. It splits the nodes greedily based on the level of entropy, so the tree splits by minimizing the entropy. So the entropy of children nodes under the parent node cannot exceed the parent node's entropy because the entropy is already minimized and is smaller than the parent node. So it cannot exceed the computed on the parent node. So that last option is true. The third question is from quiz 9. The question is about the neural network model, and we have hint for this question. Consider a fully connected neural network model taking 4 input data attributes with one hidden layer of 16 neurons and 1 neuron in the upper layer. How many parameters are needed to specify the model? As explained in the hint section, we need m plus 1 parameters in each neuron, and m means the number of inputs. And one here is called offset bias. So we have 4 inputs for 16 neurons in the one hidden layer. So the neurons have 4 inputs each. So we can multiply the number of inputs 4 and the number of neurons 16 to compute 4 inputs for every neurons, and add bias as offset of neurons. The bias is also in each neurons as 1, so the total bias here is 16. After constructing the input side, we should consider about the output side this time. So we can multiply the output from 16 neurons in the hidden layer and 1 neuron in the upper layer, 1. So, and as I mentioned, the number of offset bias follows the number of neurons. So in this case, we only have 1 neuron in the upper layer, so the bias will be 1. So the formula of input and output side is in this slide. After adding two sides, the number of required parameters for this neural network model will be 97. So the final answer is 97 here. Okay, this is the end of my video, Assessment Task 3 video pitch. Thank you for watching.